When first startled, an armadillo will leap upward. Suppose it rises 0.544 meters in the first 0.2 seconds. What is the initial speed? So the initial speed can be given to us using, again, s equals to ut plus half at squared, right? And so it travels 0.544 meters, and we don't know in how much, what the velocity is by how much, but we know it does that in 0.2 and is undergoing constant deceleration of 9.81 in that time. So the initial velocity u comes out to be 3.7 meter per second. For part B, it's asking what is the speed when the distance is 0.544. So the best equation that comes to mind is relating speeds and distance without having the need for time is v square equals to u square. Actually, we know the time is going to be 0.2 because that's what we used. So we can also use time. But let's try this out. V squared, the final velocity, is something we need to find out. Initial velocity is 3.7 squared minus 2 times 9.81 times the distance traveled, which is again 0.544. So the velocity comes out to be 1.73 meter per second. If you're getting 3.7 or something close to, again, make sure you have to also underroot the value, whatever comes out, because it's velocity squared. This will solve for velocity squared. Square root it, you'll get 1.73. So part C is now trying to ask us how much higher will it go now, right? So again, I think we can use the same formula to figure it out. It's going to be, again, v squared equals to u squared plus 2as. At this point, I want to figure the distance out, whereas v squared needs to be 0 because it'll go that high when the velocity, the max height will be when the velocity is 0. So that is equal to 0. Initial velocity was 3.7 squared plus, well, it's actually negative, 2 times 9.81 times s, and that should do it. And my final value comes out to 0.6, so not too far. No, it practically stops after. See, its time traveled is probably less than a second, or like half the time, so still less than a second. 0.697 meters. That's how much he travels. Actually, this is going to be an 8.